All right, welcome to episode 33 of we're a third of the way pretty much to 100 episodes. Episode 33 of TGI Kubernetes. I'm your host Joe Bita. I'm CTO of this startup called Heptio, where we are working to bring Kubernetes to enterprise software companies and beyond. And so I'm happy to be here today. I'm rested kind of from a vacation. It turns out that the work doesn't stop when you go on vacation. But yeah, so let's see. So I say hi in the chat here. So we have Sean, Lamatti, good to see you. Marky and Adam and Rory, awesome. So yeah, so me and the family went to the Grand Canyon and we hiked down and backpacked down and then camped at the bottom for a couple of nights and then hiked back out. So that was a lot of fun. And then I come back to work and dig my way out of email all week. So that's kind of how things go. So I'm happy that it's Friday for sure, because that means I get to relax a little bit this weekend. So all right, so who do we have? So we have Ryan and Steve. How's it going, Steve? Bob, Engine, Mauro, Arnaud from France. Saeed from London, good to see you. Philip, Lucas, awesome. Anand from RTP. And Matt. All right, Aaron in Toronto. All right, so Kris was with y'all last week. And I understand that there were some technical difficulties with the YouTube going on there. Not sure what happens. This stuff it's kind of nerve-wracking because you try and test it out, you try and make sure you have everything squared away, and then when you start broadcasting, something always seems to go wrong. But anyways, I was talking to Kris earlier this week, and she was planning, I'm not sure what conference it was, but she was planning on heading out to Toronto at some point. And I'm like, and she had a map up, and she's like, which hotel should I stay at? And I'm like, I don't know, as long as it's close to a Tim Hortons. And then she's like, what is Tim Hortons? And I'm like, whoa, back up. Because it may not be good donuts, but it's like, it's the institution in Canada, right? So that's my Toronto story of the day. So, all right, Neil, Jeremy, Siddhartha, Alex, Ryan, Alex in Chicago, Aaron, Sean. Yeah, so she doesn't get flustered easily, so I'm sure she dealt with it well. But we're learning how to do this stuff, so that's good. All right, so today, Fernando from Brazil, nice to see you. So today we're going to be talking about draft, and this is going to be the last, I think. I don't know, there's a ton of tools out there. It's really hard to keep up, but I think this is going to be the last in a series that looks at how to do development in a Kubernetes-aware way. And so we already looked at scaffold, we looked at ksync, we looked at telepresence, and then today we're going to be looking at draft. Draft is probably most comparable to scaffold, I believe. And we're going to be looking at the latest version of draft, and there were some changes relatively recently in terms of before draft had a server-side component. Now it's all client-side, so it's interesting to see how that all evolved. And then the three approaches that we've been looking at is scaffold and draft take this approach around automatic rebuild and push. So when you make some changes on your application, it'll automatically rebuild that and then push that to your Kubernetes cluster, whether it be running locally with something like Minikube or whether you're running a cluster out in production someplace. There's ksync, which is a file synchronization. So you write your code locally, and then that synchronizes out to a sort of mirror setup that's running in your cluster. And then there's telepresence, where you run your program locally, and then you bridge the network using some VPN-ish type tricks to be able to do that. And I think what we're going to see is that different approaches to this problem really work depending on what programming environment you're using, what your expectations are in terms of the interactivity with the program that you're running. So yeah, so I think I'm really excited to dig into draft. Now this is part of the work that the Azure team has been doing. And it's, I think, the idea there is to actually create a theme of projects that stretch between draft and Brigade, and then both of those, and we'll see this, depend on Helm Helm is not an Azure project; it's a Kubernetes open source, community-driven open source thing. Whereas Brigade and Draft are very much driven by the Microsoft team. So yeah, so that's what we're going to be looking at today. All right, so we have, let's see, so Radu from Romania, awesome. Sean, talking about Tim Hortons, and then Joy from Richmond. Good to see you. All right, so let me switch to my screen. I have a cluster that we're going to be using here. I just booted this up, so this is one of our Heptio Quick Start clusters on AWS. And so this is one of the things that I believe a lot of the draft documentation assumes that you're running Minikube or against one of the Azure Kubernetes services. So we're going to be doing something a little bit different from hitting Amazon, but I think we'll actually be in good shape. So I'm looking forward to seeing how that works. But I want to go through some news of the week, and I only had a couple of things here, but I wanted to go through this stuff. So the first one here is this Vault operator for Kubernetes that's been released by CoreOS / Red Hat, and this is this is just yet another example of how people are starting to adapt, and in this case it's CoreOS / Red Hat adapting Vault, which is a Hashicorp project, but adapting these things to automatically run as part of Kubernetes, which is very, very exciting. We're seeing a lot of that operational knowledge move from documents, move from Stack Overflow, move from the knowledge in the back of people's head, and then being rendered into code so that it can actually be used to automate things. And that's really, really interesting. I think Vault is yet another example of this. A couple of odd things here. Number one is it's on the CoreOS blog versus some Red Hat blog. But then also, I'm not quite sure how the branding is working out there. But the other interesting trend is that the Vault operator, I believe, reading this here, was part of the proprietary Tectonic open source platform. Tectonic platform, which was not open source. And here what we're seeing is Red Hat's taking this Vault operator and then moving it into the open source world. So that's obviously encouraging for folks who are depending upon this. And it's just great to see more and more stuff here being done in the open. So Ryan says, did they include the Vault opening logic as part of the open source release? I do not know. I haven't used this. I just think it's interesting as part of the trend, and it also, reading the tea leaves in terms of trying to figure out what exactly does the CoreOS Red Hat Tectonic open source, how is that all going to play out? And so this is definitely a data point for that. So Sean says, running an older version of Tectonic right now, but haven't seen that operator. Yeah, it looks like they said that was introduced in December 2017, so it's relatively new to the Tectonic world. So that's really, really interesting. Another thing I wanted to call out is this is a Heptio project, Ark, which is our backup cloning recovery project that we've been working on for a while. We released version 0.8 here. And then along the way, Ark is now past 1,000 stars, so that's really interesting also. One of the things that we've been continuing to do is refine the object model, the domain model for Ark, so that it really makes sense. And as we understand what people want to do with it, there's new ways for us to be able to mix and match pieces of what Ark does to actually hit more and more scenarios, and we're making sure that we can actually provide for that. So the big change here is that we redid some of the way that backup deletion works in Ark, and pretty much what Ark does, just quick thing, because we should go through this probably pretty soon on a TGI Kubernetes. But what Ark does is it captures all of your cluster state by using the API. It then coordinates to actually capture block devices, the persistent volumes, and coordinates trying to get a snapshot of those things that it can then save off and move around and work with. each of those backups then gets represented as a CRD in the cluster that you're actually backing up. And then that creates a mirror in, say, something like S3. There's pluggable backend stores. The problem, though, is that the deletion of how this stuff worked was a little bit overwrought, and it was easy to get things out of sync between what you're deleting in your cluster and actually what's being deleted in the backend stores. And so that whole flow has been reworked, so I think it's probably a lot clearer and a lot less buggy. So that's the big thing that was being done in this version. And then a lot of usability stuff that's being done here also. So some really great work seen in there, and it's good to see some good community involvement there. So congratulations to that team. And if you're looking for a solution around backup and recovery, please take a look at Ark. Let's see. So Bismarck says Vault Auto Unseal was not included in the open source release, still just in Vault Enterprise. Yeah. So this is weird because there's this mix where Hashicorp makes Vault, the open source project. They're trying to find a way to make money. Vault is one of the places where they're actually monetizing quite a bit. And there's certain features that are available only in Vault Enterprise versus open source Vault. And then you layer on top of this where Vault's integration with Kubernetes is still pretty nascent. And so the Red Hat CoreOS stuff actually doing the operator stuff that pairs with Vault. So there's like 2.5 companies involved and 3 business models, I think. I'm not sure. It's very confusing. All right, so those are the only 2 sort of new things that I wanted to announce. I might have missed something. I've been so heads down this week that I might have missed some of the other news that's come out. I try and keep an ear to the ground, but it's been a super busy week for me coming back. The other thing I wanted to do is a couple of weeks ago, I was calling attention to the Visual Studio Code extensions for Kubernetes, and I was really excited about those. I went to go play with those, and in case there's any Microsoft folks watching, it doesn't work for my workflow, and I was going to try and use those things and show this off a little bit while I did draft today. The reason why it doesn't work is that the way that I manage my configuration for Kubernetes is that I have a separate kubeconfig file per cluster that I'm dealing with instead of trying to cram everything into the big file like a lot of other folks do. And VS Code does not support, this VS Code extension does not support being able to override which kube config you're using in an easy way. So there's a bug open on that. I just wanted to call attention to that. I'm hoping at some point, I wish I had time to be able to roll up my sleeves and get it done, but I'm hoping that this will get solved and then maybe I can start showing this off a litlittle bit. And let's see, so Nadir says that for AWS and GCP users, you can recommend the JetStack Vault Unsealer. And all right, so yeah, so I haven't played with that, so maybe that's a good companion project for Vault. And then Sean says that new tool naming voting on Kubernetes kube-deploy for 3 more days. I haven't seen that, so let's do Kubernetes kube-deploy naming. Let's see what we get when we do that. Do you have a pointer, something that I can Google for that, Sean, to get it? Because like we all know that URLs don't work in the comments here. Let's see, is there? That's not it. I got a 404 there. What do we got? A place for cluster deployment automation. So yeah, I hadn't seen that. I must have missed that, Sean. So yeah, if you have 3 issues in, okay, it's one of the issues in the repo. Okay. Oh yes, was this? Am I confused? I think I know this. Okay, this is fascinating. Okay, yeah, so let's load this up. There's a lot of comments here. So this is funny because, so kube-deploy is part of the, sort of one of the projects that's part of the cluster API stuff. And there's work in terms of what will the sort of client-side tool be. And there's a lot of really fun names here that are hilarious because there's things like cluster cuddle. Or cuddle. And so, yeah, so if you have ideas for the name for that, yeah, and then Kris is involved, so people are calling it Kris Cuddle, Kris Control. That's pretty funny. So yeah, so go ahead and vote that. I'll definitely put a pointer to that in the show notes. All right. Any other sort of news of the week that folks want to call out? before we move on to really digging into draft. I'm going to say let's just start looking into draft. Saeed, so is Kubernetes Federation real? And perhaps a TGIK on it. Kubernetes Federation has, I haven't been super involved in it, to be honest, so I don't want to like misrepresent what's going on there. My understanding is that there's a little bit of a reset and a rethink over some of the stuff that's going on with Federation. That stuff got moved around and the SIG got renamed from SIG Federation to SIG multi-cluster, which is the idea of how do you start managing across multiple clusters. I've seen a few reviews and sort of like talks here and there in terms of some of the efforts that are part of that, but I don't think I have a super deep understanding of what the current state there is. My personal feeling here is that there's doing federation in a smart way is actually really difficult. There's a couple of things to keep in mind here. The first one being that you need new concepts as you move from a single cluster to multiple clusters, right? Just like moving from a single node with running Docker to Kubernetes to deal with the scale, to deal with the issues across multiple nodes, to deal with a lot of the new problems that come on when you start sort of like looking at this stuff in a multi-node world, you need new concepts. And so I think one of the things that makes Kubernetes work well is that the concepts are cluster native versus trying to make the cluster look like just a great big old node. And I think you see a similar type of thing when you go from a single cluster to multiple clusters. When you start using this thing for real across multiple clusters, you can't just take a bunch of clusters and make them look like one big cluster. There ends up being, speed of light issues. There ends up being reliability and management issues. And then a lot of times, the reason why people want multiple clusters is they're running in multiple regions, running in multiple clouds, running in multiple AZs perhaps. And they're looking for reliability. And there is a danger, and this is part of what you have to consider, is that if I create one system to control them all, is that going to become a single point of failure? Or is that going to be something that's dangerous where if I screw up configuration there, now it takes down a bunch of things across all of my clusters? And so I think there's some really subtle, considerations to take into account, beyond just sort of, hey, ease of use, I want one point of contact. Where you have to think about sort of like what are the risks? Why am I doing multiple clusters? And by doing federation, am I actually undoing some of the benefits that I was looking to get from multiple clusters? Paul says, if you can say, had Google's Borg properly solved the multi-cluster federation issues, there was a pretty bleeding edge stuff. It's different in Google. So one of the things to keep in mind is that in Google, the tool set, and I think this is something that we haven't done a great job of in Kubernetes, is that the tool set supports multiple clusters very, very easily. Each cluster has a name, and you can easily retarget tools across clusters. And then there's tools that actually help you to say, if I'm doing an application rollout across 10 clusters, I want to first do it on this cluster and then wait for human intervention for somebody to say, okay, I want to go through and do the rollout across the rest of the clusters. So you're doing sort of a slow type of thing. When you're looking at capacity management, there are tools to say, hey, I want to run something. Which cluster has the capacity for me to run this? That gets really tricky because, most of the time you're not running purely stateless stuff. So it's a combination of where do I have capacity, where's my data sitting? Where do I have bandwidth? How do I want to make the trade-offs between using my bandwidth, using my capacity, and how soon do I need this? Those trade-offs are not obvious to be able to be made. And then a lot of times there's this idea that once you do launch something and it picks sort of like, hey, where do I want to run this? You may want a bunch of things to actually run co-located in that cluster. And so that means that if you had some sort of federation-y system and you're building a microservices mesh, you want to make sure that it understands the topology of the mesh and understanding, hey, if I place this thing here and this thing here, that's sane, whereas if I place these other two things, those things need to actually be right next to each other and latency really matters. So those placements across clusters and, especially in a sort of microservices mesh type of thing, become really, really tricky, and there is no one-size-fits-all type of thing here. You see similar issues when looking at autoscaling, like horizontal pod autoscaling, right? if you naively say, hey, I'm going to look at CPU, and CPU spikes, I auto-scale, that's great, except for a lot of times that thing that's showing the CPU spikes may not be the thing that is your bottleneck, right? It may be that your database is the bottleneck and your application has poor behavior when the database starts backing up, and that fools you into thinking that the front, the thing in front of the database, the service in front of the database is the bottleneck. You then increase scale there, and maybe you just made your problem worse, and it's that much harder to recover. So a lot of times when you're looking at distributed systems, the easy answer is not always the right answer. All right, so that was a very long-winded explanation for this stuff, but I don't feel like there's a silver bullet here for this stuff. There's still a lot of stuff to take into account. All right, so that's quite the digression. Let's start digging into draft a little bit. So draft.sh, as we is the fancy site here. It's a Microsoft project, like I said, and they have this cool little animation here. This is, I think, like a single page thing, because if you start looking at this, that does that, and then the docs just takes you to GitHub. So that website, draft.sh, is a pretty thin wrapper on this. The docs, so there's a getting started here. It's in the GitHub repo, but also if you go to the README, you can start seeing what's going on here, and I think there's a very, very hard to read GIF or something. Oh, wait, no, this is okay, ASCII Cinema. That's what I'm going to call it, because I always read it as something else. I'm not going to say that. That actually goes through that. So we're not going to watch the video there, but that actually shows you a little bit of how that works. There's an installation guide. We're going to go ahead and look at that, try and figure that out. And then there's getting started, which looks really good. That gets you up and running. One of the things I do want to, and as I was reading through this, I saw the license down here, and Draft is an MIT licensed project. Most of the rest of the stuff in the Kubernetes world is Apache 2. The big difference, well, is there a history here on this stuff? So they back in April, they switched to the MIT license. From Apache 2. The big difference here is one of patent encumbrance, right? So one of the things to keep in mind here is if you do start building on Draft, Microsoft still is not granting any patents along with that. So, practically, that's probably not something to worry about, but depending on sort of how much you're using this and whether you're donating code or what have you, just recognize that that's something that you should probably understand. That's the main reason why the rest of the Kubernetes world is on Apache 2, is that we want to make sure that folks are up to date and not donating code that they hold patents to that they can go ahead and sue you for using their patents. Again, Microsoft has had a checkered past on that stuff. There's the new Microsoft and the old Microsoft. I myself have probably have a dozen Microsoft patents under my name that Microsoft owns, so I'm part of the problem there. All right, so there's that. All right, so let's go ahead and get this thing installed. I think we're going to be doing the cloud provider install guide because I'm going to be working against AWS. So I'm going to go ahead and click on that. And updated 3 days ago. So it says, in certain situations, users are given a Kubernetes cluster with security constraints such as needing to push and pull containers images to and from a remote repository, only being able to deploy applications to a certain namespace, or running applications in an RBAC-enabled cluster. So that explains all the stuff that we want to do. I don't think we want to necessarily assume that you're root on a cluster to be able to do this stuff. Let's see. Drafting in the cloud. When using Draft with blah, 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 EKS, I'm pretty sure the Microsoft folks do not have access to EKS yet. We need a way to distribute the built images. With Minikube, you can just build on Docker and you're using the same Docker. And then with the cloud stuff, you have to push to a registry. And so we'll set this up with ECR. Oh, did you lose sound? You said you lost me for sound. I'm still... Did other folks lose sound? No? Okay. Muzaffar, I think it's just you, unfortunately. I apologize. Okay, hopefully. Okay. All right, so we got a lot of other folks are saying that they can still hear me. That's good. I see moving green bars and stuff, but you never know with this stuff. All right, so we got to deal with pushing and pulling to registries. And then let's see, drafting. So you can set the registry that you're using, and then you can log in. This is with Azure, Docker Hub, and then there's running tiller with RBAC enabled. Okay, so this is not, okay, so, all right, so the install instructions here just dump you right into the middle of stuff. I guess I guess we can start with the Minikube ones. So I don't want to start with Minikube, but I can, okay, so we can actually go through and do this. And this also assumes that you're running on the Mac too, which is fascinating. We should try this from Windows and see how it works. Okay, but we can go through and we can tap the Azure draft and then install it. Oh, and Homebrew has to download the internet. Okay, it's weird that I have to go to the Minikube install instructions to install draft when I'm not using Minikube, but let's see how things work here. We'll try and sort of cobble something together. A little off the rails here. And then we have to install Helm, but I'm running against an RBAC enabled cluster, so that's not going to work either. Okay, then we'll go to the cloud installation stuff. Okay. Yeah, and I don't have Helm installed here. I wanted to, all right, so now, okay, so that tapped draft, and then I can do this. And then it says, now that draft has been installed, set up draft by running this command, draft init. This will prepare draft home with the default set of packs, plugins, and other directories required to get you working with draft. All right, so let's just follow this stuff. Okay, this is downloading. Windows.net is slow to download. Azure draft.blob.core.windows.net. I have something like, I just did a speed test before this because I wanted to make sure we were set for YouTube, and I have something like 400 megabits per second downlink to this computer, at least through a web browser. So, all right, so there we have draft is running. Okay, and we do draft init, sets up a local environment. So the thing that confused me, it's not clear exactly what this is going to do because Helm init goes through and talks to your cluster and does a whole bunch of stuff in your cluster. I don't think this is the case. I think this just does stuff locally. Local configuration of draft home with a bunch of stuff. So I think I'm safe doing this. But why does it need to know? Oh, that's a global flag. Okay, so we can do draft init. So this is okay, creating a bunch of stuff. We have a config file, packs. What are packs? We'll figure out what packs are. All right, happy sailing. Draft home has been configured. Let's see what that looks like. What did we just do there? So we have a config file that has nothing in it. We have plugins, which has, what is this? Draft plug pack repo. It's a symlink. What's a symlink to? To packs, I guess. This is a symlink, and then cache is where this stuff is. Okay, weird. So it's doing a bunch of Git stuff here, and then and so we have, so it actually syncs all of draft, the draft source code into this, and then we also have plugins draft pack repo. Okay, so it downloads draft as part of installing draft. That's a little strange, but I assume that it's probably not grabbing everything out of those repos. It just probably needs a few things here and there. Something to keep in mind there. I wonder if you have to update that as things change. Unclear. Okay. All right. So we got that happening now. And now it's saying boot Minikube, but we're going to stop that. And then it says install Helm. Now we're not going to do the Helm secure configurations. This takes us to Helm. But then if you also, this stuff is a little bit cloud installation documentation also has how to install Tiller with RBAC enabled. Now, there's two security issues that folks should be aware of with Helm and Tiller. The first one is RBAC, in that, like, by default, when you do Tiller on an RBAC-enabled system, it just won't work unless you give it some permissions. The easy thing to do is to give Tiller root. There's ways to scope it down, and that's one of the things that these instructions go through. The other issue is the communication channel between the Helm client and Tiller, and that's unauthenticated, unencrypted by default also. And that's actually, in my mind, probably the more dangerous issue. The instructions here, and both this and what's pointed to here, deal with just the RBAC issues and how to RBAC enable things to get working. They don't deal with the issue around locking down the Tiller ports. Because, hey, this is just my development cluster, I'm not going to worry about things. We're not going to actually dig into that too much here. But what we need to do to get Tiller up and running is we need to create a service account here. And this is installing Tiller into kube-system, which is also an interesting choice here also, and we'll get into that as we go through these instructions. So we're going to create a service account in kube-Tiller, which this means that this is going to be credentials that Tiller uses to talk back to the Kubernetes API to do things. And then we need to create a role for that, and this is interesting because we're creating a role that will only work in the default namespace. So we're not creating a role for, so we're only going to give Tiller theoretically access to the default namespace, which is good because, there's this issue of like, how do, if somebody were to compromise Tiller or get, access to Tiller, what inside that cluster will they be able to do? A lot of the instructions you'll read out there are like, hey, just give Tiller root. This is trying to scope that down a little bit. And then Matt Fisher's who's on here, it says like something to keep in mind is Helm 3. There are some really interesting proposals out for the next version of Helm, which is going to move a lot of this stuff client side and start utilizing a lot of the authentication authorization mechanisms of Kubernetes in a more native way. So a lot of that stuff is going to be resolved as that stuff keeps going forward. Matt, do you have, like, if I do a search for Helm 3 design doc, I don't know. I saw something, and I know that there was stuff going on. I don't have the design doc handy. I think there's been a whole bunch of sort of like, hey, what do we want to do stuff there? And I think the Helm folks are starting to converge on sort of what that plan is there. I'd love to include, a pointer to that design doc in the show notes and go through that for folks that are interested. Kubernetes-helm/community is where it's at. Okay, let's check that out. Kubernetes Helm/community. And then Helm v3 is going through a lot of that. Okay, cool. So this is continued to make progress there as these folks try and figure out what's happening. There's some really interesting ideas here. Last I looked, at least, including, and I don't know whether it still is part of it or not, but there was also, embedding Lua was what was part of the plan at one point too. I don't know if that's still the case or not. So if folks are interested in sort of what the future of Helm looks like, this is the place to go, and I'll definitely include this in the show notes too so that folks can see that. But that being said, okay, let's go through the example here to actually install this in an RBAC thing. So we're going to go through and okay, I'm going to close that one here. I have this. We're going to call this file role-tiller. Let's see if, and is this in the right place? No, that's a Minecraft mod thing I was doing with my son. What directory is that? Let's do it this way. We're going to do new file, role-tiller.yaml. We'll go do that. So let's decode this a little bit. What this is saying is that we're creating a new role called Tiller Manager in the default namespace, which means that and this thing is of type role versus cluster role, which means that when we bind this to a service account, it'll only have access in this particular namespace. And then what it's saying, and this is a little bit, it's saying that across sort of like the core extensions and apps API groups, you give access to all resources, all verbs on those resources. So this is pretty broad access. This is, probably equivalent to, say, root inside of the default namespace here. Oh, Muzaffar, I'm glad that the sound came back for you. That's awesome. So we'll go ahead and do that, and then we'll kube control apply -f role tiller. So that's done. Now the next thing we need to do, so we did that, is that we have to do a role binding. And so this says who are we going to give those permissions to? And this one is called role binding tiller. Okay, so we'll go ahead and do that. Role binding tiller.yaml. And what this says is that, and this is separating this from cluster role binding, which says across all namespaces. So this is actually working within a specific namespace also, that the kube system tiller service account that we created with one, don't mind Bitcoin. I'm not exposing this to the world. Don't worry, we're not going to hit that thing again. But the kube system tiller service account, which is in the kube system namespace, will get access to the tiller manager role in the default namespace. So this is actually allowing a service account in one namespace to do things in a different namespace. So this is a cross namespace linkage here. So we'll go ahead and we'll do this. So that's up and running. And you'll have to do something similar for every namespace that you want to give tiller access to. And then there's one other thing that needs to happen here. And that's, so we'll also need to grant tiller access to read config maps in the kube system so it can store release information. And it's not just reading, this is also writing config maps. And I think this is actually really dangerous because it's happening in kube system. And we're going to do this anyways because I don't want to take too much of a digression. But if we do, like, say, kube control get -n kube system config maps, what am I doing? Oh, get. If I look at this, what you'll see is that there's some pretty sensitive configuration here that tiller will have access to, right, including my network configuration, proxy configuration. The kubeadmin stuff isn't part of it. But over time, what we're going to see is that more and more sort of control plane configuration, including how kubelets are configured, how your API server is configured, and all that stuff, is going to be moving to be config maps inside of the kube system namespace. And so one of the things I think to keep in mind is that, like, giving anybody any access to write anything in kube system is going to be very, very dangerous because they can go through and modify these things and subvert this stuff. It's not quite as bad as giving them secret access because that's even worse. But that is, to some way, this is like giving folks write access to /etc on your Linux system. So Matt says it's very easy to install. So yeah, so one of the things, and this is the difference, and I think this is just the configuration story is a little bit twisted because if you look at the Helm documentation, they also talk about how to install tiller into non-kube system stuff so that you can actually sort of protect yourself from that. But what I didn't want to do that for this because then I don't want to figure out how do I configure draft so that it actually knows to talk to a tiller in a different namespace. Same thing with doing all the TLS setup and stuff like that too. So I just want to be like if you're doing this for real, if you're running this, it's probably best practice to install tiller into some namespace other than kube system. All right, but we're going to go ahead and do that now. And so we're going to create something called role tiller kube system. And that source is here. And then we'll go ahead and we'll install this. So this doesn't do anything in and of itself. This is just defining the role for the kube system namespace. It's really the binding where things happen. And here we're doing a binding from the tiller service account to that. And this thing is called role binding tiller kube system. let's copy paste this puppy. And there we go. So now we got that up and running. And now we can finally install Helm with Helm init. Boom, boom, boom. And that configured that. And now if I do kube control get pods and kube system, if I can type right, I do have one of the Mac keyboards, we should see that tiller is up and running for 11 seconds. All right, so we're up and running there. All right, so then here's like running tiller in a namespace other than kube system. Oh, there is, okay, here's the instruction. Okay, so we could have done this also then. All right, so yeah, I would probably say this is probably a good idea to do also, is to actually run that in a separate namespace from everything else. But all right, so now we're up and running there. Now the next thing we need to do is we need to actually tell draft which registry to work with. Passing the registry server URL without the protocol scheme. So we're going to go back to the AWS console, and if we look at ACR, will that take us there? No. Yes, it's actually under the Elastic Container Service thing. We have here repositories. Oh, this is a bunch of stuff left over from before. Let's delete those. And so one of the interesting things here is that most of the other registries out there, the first time you push something is when something gets created. The Amazon registry actually works differently in that you have to explicitly create a registry before you can push to it. And so I'm not quite sure. Let's try and figure out sort of how that's going to apply here. Yeah, and I think that there's confusion between sort of the registry API endpoint or the base of the registry versus the actual registry that you're actually pushing to. And a lot of times I think people assume that they can break that stuff up a little bit. So it looks like what we're doing here is we're setting the base of the registry versus actually just going through and setting the registry itself. So let's see, you can just do username if you're using that. There's no instructions for Amazon, but let's try and see if we can fumble our way through this. So let's create a repository. I always get confused. Okay, so repository is the thing that you're actually pushing for. Registry is the API endpoint where you push repositories. I believe that's how this stuff works. And so Matt Fisher says, yeah, it's the same name that you'd use for Docker login. So let's call this one draft test. And so here, I think, so now what we want is this will be the registry that we want to use. And then we can do stuff like this here. Retrieve the Docker login command. So this is the wackiness with ECR, where I can go through and I do this. And, oh, what do I do? Oh, wait, no, I got to do, I'm going to, I don't want to expose some stuff real quick, so you're going to stare at my face while I actually, look at something here. Because get my setup right. Config, am I anything? All right, so let me switch back here. So the way that AWS works is that the AWS command line, you can have different profiles and stuff. And so I have something called AWS profile equals demo, and then I do this. And what this is actually doing is doing a short-term token to allow Docker to be able to log in to AWS. I believe this lasts something like on the hour of minutes or hours. So you can't, we talked about this. I did a TGIK where I talked about registry, so you can take a look at that if you want to understand how that works. But if I execute this command, now I'm logged. Oh, no, I don't have Docker running. I should probably do that. Let's see, it's going to want to update, I bet. $10. Let's see. It's going to update. Maybe. Come on, Docker. You can do it. I got the Docker thing going on right now. Docker is starting. Sorry about that. I should have been better prepared here. So what's going to happen with Draft is that it's going to do builds locally, and then it's going to use the credentials that I have on the screen here, which if you guys steal it, I guess you can go ahead and push stuff to my Docker registry. Please don't. That's a lot of stuff for somebody to type for very little gain, so I'm hoping that we're going to be in good shape here. All right, so now I can go through and I can do that, and we're up and running. And so now I've logged in there for that registry. And then I need to take that same, and then this ends up being the registry that we're going to use for Draft. So it's draft config set registry. I believe that will work. All right, so, and okay, so I think we're all set up. All right, because we have Draft installed, we have Helm installed with Tiller configured for RBAC. We have Draft now and Docker now configured to deal with the Elastic Container Registry. I assume that's what ECR stands for. So I think we're all up and running now. So now the next question is, what should we do? Let's start using Draft. So take Draft for a spin. So let's do the Getting Started guide. All right, so there's an examples directory. So, okay, so I don't have this cloned locally. So we're going to go through, copy that, git clone, boom. So we're cloning the Draft repository just so that we can use the examples. You wouldn't need to use this normally. And so we can do Draft examples. And there's a whole bunch of examples. So this is actually really fascinating. So this one is saying we should use Python. So let's go ahead and use Python. Oh, it says examples, example-python. Yeah, Python. There we go. All right, let's see what we got here. Let's see if I do app.py there. Okay, so this is doing nothing more than linter, pylinter is not installed. Shut up. So this is doing nothing more than using Flask and doing an app.run on port 8080 and saying hello world. But to get Flask involved, you have to have a requirements.txt there, which is the awesome. Okay, so now, okay, so we got that up and running. So now I should go through, and so if I was a Python dev at this point, I might be using virtualenv or something like that to be able to sort of set up my own environment. But that's not what we're doing. So instead of using virtualenv, we're going to be using Docker container and Draft to be able to build that Docker container and then automatically deploy it every time we change stuff. So now we need to create some scaffolding to deploy the app. So Draft can create a Helm chart, a Docker file, and a draft.toml with Draft create. So if I do this, magic happens. It says Draft detected Python 97.267760%. Percent of something. I think that's confidence or the amount of code or something like that. Ready to sail. All right, so we are, and let's check out what it ended up doing here in this directory, because I think what we have is it created, oh, there's a Docker ignore there. So it created all this stuff. I don't see like a, why is Git not seeing this stuff? Because this added a bunch of files, right? Huh. I'm trying to remember. So we just had app.yaml and requirements.txt, but when I do a git status, I just see the Docker ignore that's being added. I don't see draft.toml being added. Will that get checked in or? No. Sean says maybe a top level git ignore, ignoring those files. Perhaps. That's what I was checking. I don't see. Oh, there's a git ignore. Okay. Yeah, so there's the example ** Docker file charts, whatever. Okay, so I think what normally would happen is that if you were running this on your own project, you'd want to make sure that you check all those files in. But because we're using the examples directory, I'm guessing that the draft folks didn't want to accidentally check in the stuff that, like, you know, you want to actually make part of actually running the example. Yeah, okay, so that's, all right, that's the confusion there. All right, so now what do we have? So we have a Docker file here, which is using the Python onbuild, which is one of the standard things. It doesn't say which version of Python, so I assume we're talking Python 3, because that's going to happen someday. We have a draft.toml that says name is example Python, namespace is default, wait, watch, delay, and auto connect. I'm not sure what all this stuff means. My guess is that example Python is going to be the name of the image that we're actually going to try and push. Unclear yet. There's draft ignore that says, I guess, you know, these are all things that draft will not auto rebuild on because these things change and they're not going to have any impact on the end result. We have Docker ignore, which means these are the things that we're not going to push to the Docker build process. So when I can go into some detail on how the onbuild Docker files work, it's a little bit confusing here. And I think that might be a good digression if we have time. And then there's charts here, and what we see is that we end up with a Helm chart. And this, and let's see, so we have the chart.yaml. It says a Helm chart for Kubernetes Python. So this doesn't specialize it in any way. And then the templates are, there's the standard curly brace party going on here with Helm charts. And I believe, so there's a notes, but I believe what's happening, why do we have charts, Python charts? Is there charts within charts? Is this like subcharts or something? There's a Helm ignore there. Okay, and then the values here, we have the image, service, ingress. I'm not quite sure where the image name comes from. I guess if we look at the deployment, and this is going to try and set up ingress too, if ingress is enabled. But if I look at the deployment, then labels, draft apps, containers, values.image.repository. Values.image, there is no repository there. So that must be standard charty stuff. Okay, so, all right, so we have a chart there. That seems to be working. Now, if I go through and, so the chart and Docker file assets created. Docker file harnesses the Python onbuild. We can talk about that, which is, there's some magic going on there that Docker does. Yeah, and then the name is the name of the chart, I guess. Is it also the name of the image? See, dep 6 for informational available configuration of draft.10. Oh, there's deps. We have deps. Okay, so this goes into some of the detail. The name of the application, this will map directly to the name of the Helm release. The registry to publish it to. What is the image name? I don't know what the image name is going to be. We'll have to see. We'll run it and we'll see what fails because it's going to fail the first time. Now when I do draft up, what is it going to do? It's going to go through and reads the configuration from draft.toml, compress the chart directory, and the application directory is two separate tarbells, builds the image using Docker. Docker pushes the image to the registry specified in draft.toml or the one that we set. And then draft instructs Helm to install the chart referencing the image just built. Boom, let's do it. All right, draft up. So this is going to fail. I know this is going to fail. Okay, so we have example Python, building Docker image. So we're building the Docker image right now. So what this is doing is this is downloading onto my computer that Python onbuild image. It's then going ahead and running that to actually build. As part of that thing, it's going to be downloading and doing the requirements.txt thing. So it's going to be downloading Flask into that Python image. Any of the things like this and Scaffold both, where you're doing this rebuild, the first time you do this stuff, it's actually gonna be slow. But the idea is that you're just caching a bunch of data, and so you won't have to do that every time. So it failed, which I expected it to fail, in the image push. And the reason why is that the repository with name example-python does not exist in that registry. And so, and again, I assume, is it the... So example Python is the name of the Helm chart and also the name of the image relative to that. So we did like draft test here. We don't want to do that. So we're going to go through, we're going to delete that repository, and then we're going to create a new repository called example-python. Next step, here's all that gobbledygook we don't have to do again. We can hit done there, and we can see that there's no images going on. Now, if I do draft up again, building the image will be super fast. Pushing the image, the first time you do a push, it's going to be slow because you have to push all this sort of base parts of the image there. But then future pushes will be faster because you'll be able to leverage the layers that are going on that are already been pushed. The interesting thing, and we can look at this, is that every time I do a build here, we'll have to re-download Flask, or is the Docker the Python on build smart enough to actually keep the same layers for those requirements.txt? So we'll actually have to see that. And then releasing the application, and then draft logs, we actually can go ahead and look at that. Is this the same? Yeah, so now we went through and we pushed, and we're up and running, which is great. And the name of the image is this long hexadecimal thing, which is interesting. I'm not sure where this comes from. Is this a hash of the content of the thing? So this is, I mean, and Scaffold had a similar issue going on here, whereas what happens is that you end up with a whole bunch of images here, and they're tagged with a really opaque marker. I think, making this be something where you at least have the date time so you can sort these things and actually figure out what's going on might be useful. Using a checksum here makes sense because you're not going to end up pushing things that are already there. But like with sharing of layers, it probably shouldn't matter too much. All right. And what we see here is that we built something that's 262 megabytes. And we have one tag here in this repository. Now, the reason why Amazon did ECR different, and I think this is an advantage of ECR over at least GCR, Google's registry, and I'm not super familiar with Microsoft's, is that you can set individual permissions on an image-by-image basis, so that you can actually sort of say, hey, this set of folks in my account have permission this way, this other set of folks have permission this other way. With Google, the permissions are global across the set of images in the repository, and there you can only have one repository per project. With Azure, I think you can have multiple repositories. You can create those things, and they can be scoped to resource groups. And so out of the three sort of major cloud registries, you can have multiple registries in Azure, and you can only have one registry per project in Google. Sorry, registry, repository, very confusing. So I think out of the three of them, I think Google's is actually the least flexible. Okay, so now we have that thing up and running, and if I do a docker or kube control get pods, we can see that the example Python is running. Deploy. I don't know why it's called example Python. That's probably part of the Helm chart. So we have the template for that thing is the full name of the thing. It's not clear to me sort of which parameters are pushed by draft and which parameters are actually part of the Helm chart. And and what's interesting is that I think, so there's a releasing application. If we look at the logs just seem to handle the build. One of the things I would love to know here is to see a clearer delineation between where draft ends and where Helm picks up. So I think, having at some point, and maybe it's buried there someplace, to have something along the lines of like, hey, if you want to like release the exact same thing you did with draft with Helm, here's the Helm parameters, command line, or whatever that you need to do, right? I think drawing that connection between the development and as you actually go through. Helm get values. Okay, so we can pull it back out of Helm. Get values example. Well, Python, I assume, is what you mean, Matt. There we go. Okay, so the parameters coming in is that we have draft, we have a build ID, we have draft example Python. The other thing that confuses me a little bit about Helm sometimes is that you have this values.yaml, but this is not like, it's more dynamic, like say Python or JavaScript, where it's like you can add more values just by like throwing stuff in there, then the templates can do it, versus something like C or C++ where you have to declare all the values that you might be using up front. And I think there's different approaches to this. I mean, on the one hand, it means that you don't have to, like, if you want to add a new parameter to your Helm chart, you don't have to go through and correct me if I'm wrong, Matt, you don't have to go through and plumb everything through, which is nice because you don't find yourself editing 12 files to do something simple. But from the point of view of a consumer of a Helm chart, you don't have this sort of like, hey, what are all the parameters that this Helm chart's using? And so, because I see here, we're passing in parameters like build ID and draft that I don't see any place here. And so I'm like, how are those things used? And to figure out how build ID is used, I have to then go start looking and delving into the templates themselves to find that I don't know, is build ID? Yeah, here we have build ID becomes an annotation on the deployment. In the template of the deployment. I'll tell you why they need to do that also. Is that if all you're doing is updating things, you want to make sure that you force a change in the template, even if it's just an annotation change, so that the Kubernetes deployment will actually re-roll things. Okay, and then here's the image repository and the image tag. So we actually have that up and running. Okay, cool. Now, but that was just a one-shot thing because we did draft up, right? And if I do this again, in theory, this should be a total no-op. And we, because nothing changed, we don't have any new image tags, and kube control get our describe deployment example Python. Let's see, did it actually? Yeah, so yeah. No, it actually, okay, so this is interesting that I wonder what changed, because I did a draft up, and that re-rolled my deployment even though nothing changed. And my guess is that each time I do that, let's go through and we'll do the Helm. Where was that Helm command? What the Helm? Helm get value. So if we do this again, what we'll see is that the build ID, so this is ends with 8D8. Did that change? I am confused. Where is the? I'm sorry. My scroll back history is confusing the heck out of me. You'll have to excuse me for a second. Okay, yeah. So the build ID changed. So every time you do a draft up, it'll do it'll increment the build ID. That gets plumbed through into the template for the deployment, and that causes the deployment to re-roll. So there's a conscious decision that because of that if you do draft up, even if there's no changes, it'll go through and actually do a restart of your process. So yeah, so Matt Fisher says tar.gz files have a unique M time, so it generates a new checksum each time. It's a bug, but it's fixable. Okay, so it's using M time to do this stuff, okay, which is the modification time, because it creates this intermediate, and that intermediate is the thing that derives the That derives the build ID. Okay, so it's not a conscious decision. It's just sort of like the way that some of this stuff. That's probably not a big deal because, you know, if you're doing development, the whole model of draft is that you're re-rolling your deployment all over the place. All right, so let's keep reading some of the stuff that's going on here. So we did draft up. So now we can do, now that the app has been deployed, we can connect to it. Oh, so this is nice. So now we can do draft connect. And this does the magic stuff to actually connect us to, let's see, running on connect to Python 80, what, okay. On localhost 5, I'm confused. And then running on this. So it says if I go to that, it says this site can't be reached, so that's not it. Oh, you know what? Okay, this is really confusing. So if I go, so this is what I want to actually connect to locally. All right, so there's a lot of stuff going on here, and I think I've figured out what's happening. Well, that doesn't seem to be working either. Oh, there we go. Hello world. Okay. So, all right. So here's what confused me here, and this is a quirk of the Python stuff, is that this is, so when you do the draft connect, it looks like it's doing two things. It's looking at all the exported ports that are actually involved there, and then hooking those up. So it's forwarding localhost, and it picks a random port locally to that. It's probably using kube control port forward under the covers to be able to do this. I bet you if we did a PS, we'd go ahead and see that. To port 8080 on the Python program. And then it's actually showing you the log output of the stuff that you're actually doing. And that's what's happening here, is it's essentially doing log output of this thing, similar to that utility that I've been showing off here and again called Kale. So it's doing a tail of that. And the Python here that we're seeing, and this Python here is, I believe, the name of the container, perhaps. Not the pod. But I'm not sure what Python colon 8080 here is, because that path. So let's go through, and if we look at the deployment, here we can see that there's port 8080 that this thing is actually exporting, but I don't see, I'm not sure where that Python string came from there. Oh, that came from the, okay, that came from the container, right? So this container is exposing port 8080 going on there. Yeah, okay, cool. So that's saying, okay, so I'm port 8080 on the Python container inside of that pod is being port forwarded, and then we're going through and then starting to show the log stuff. And so this log line here, which confused me initially, is coming from the point of view of what's happening inside the container, not how things are being mapped through. So that's what's happening there. Now, I suspect that there's a little bit of sleight of hand going on here, and I'm going to call out the draft guys, because if I change my program to, well, no, I'm not going to go off the rails yet. We'll get to that. There's this question of, like, how did this thing know that it was port 8080? And if we go and look at the Helm chart here, what we'll see is that this container has a port. It has a container port, which has a service internal port. That service internal port is now here, which is hard-coded to 8080. So it just happened that their example application knew to listen on port 8080, and the Helm chart made that assumption also. If my application decided to listen on, say, port 9090 instead, or if I wanted to plumb through, say, 443 here, this journey would not be quite as smooth. I'd probably have to go through and change the Helm chart and to reflect that other port that I'm using. But let's see if I change this to port 8081, and then I'm going to change app.py to 8081 also. Now if I do draft up, It's hard because there's only so much interest. So imagine that this is an unsolved problem across the entire Kubernetes ecosystem. The ideas like metaparticle are interesting. Yeah, so there's only so much introspection you can do into a program to say, hey, which ports do you expose? There's pluses and minuses to metaparticle, which is Brennan Burns' other Kubernetes co-founders' approach to this, where Brennan's idea around this, at least one of the things that's in metaparticle, is that applications become self-deploying. And so that way that the application knows both how it's running itself, but then also knows how to program the Kubernetes cluster that it's deploying itself to. That solves this problem, but it introduces other problems, because then there's questions like, how do you coordinate across multiple microservices? How do you create, resources that you want to configure outside of what that program knows? And so I think we're still figuring out exactly how all that stuff actually works together. So Matt Tucker says the Ruby pack uses a default of 3000. Is that the standard in that community? I believe other packs use 8080. And Matt says, I'm not prescribing metaparticle. No, it's a hard problem here. And so, but I think there's a trade-off to be made between sort of the happy case versus like if I were using Draft and I had a program that I was applying this to and I didn't happen to use port 8080, I would be like, Draft Connect broke, right? And I'd see that 8080 there, and I might realize that, hey, my thing's serving on 8081. What's going on? And I'd have to start plumbing through, and actually all of a sudden now I'm authoring Helm charts and digging deep into this stuff. So that's, the example that, and obviously everybody does this when they're demoing their stuff is the happy case here. So we did a draft up here. And if we go through and if we do describe, if we look at that, now we'll see that this thing is now 8081 is the port. And if I do connect, Draft is now smart enough to say, hey, I'm connecting to this thing. Let me port forward for all the exposed ports from that particular deployment. And so now the other thing here is that this actually picks a different local port. So every time I do a connect, I'm actually going to have a different local port. So Sean, you never heard of metaparticle? Oh, well, you obviously haven't sat down with Brendan, because he'll talk your ear off on it. There's some really interesting ideas on that, in that. All right, so this is still, I think some stuff is still coming up, or there might be, I wonder what's going on here. Why is this not working? Not going to dig into that right now. So if I do kube control, port forward, deployment, example, Python. $80, $81, $80, $81. So that's deployments. Oh, it's example Python. Sorry. So this is actually, so we're doing the port forward a different way. This is the latest version of kube control, the 110 one, actually knows how to actually deploy port forward to a deployment. So it actually makes this stuff a lot easier. And now I can do localhost 8081. Is this working? So that's working. Oh, now I'm getting. It could be something with Flask. I think we might have hit this before. It could be something screwed up with my with networking in my cluster too. Not sure what's happening there. Didn't we hit this the other day? Trying to remember what was going on here. All right, error creating stream, timeout occurred. So something's going on here. All right. Anyway, so, okay, so that, it looks like things picked up, and there's some sort of weird thing going on here that I probably am not going to take the time to debug right now. Okay, let's go onward. So now we can do, okay, so we can do draft connect. Let's just do that again. And, Okay, and so the example here says that, hey, it's going to try and do 8080 to 8080. But in my code, and maybe this was something that is like a newer release of this, it's if I do curl localhost, it actually picks a separate port. So maybe that's something that changed from the documentation. All right, so this is working. Something with the browser is going on, or maybe something was warming up. Okay, once you're done playing with this app, cancel out of the draft connect. Sure. And note that you can use the flag. Oh, so you can do this in one thing, which is auto connect. I wish there was a way that I could say, here's the local port that I want you to use also, because that would definitely eliminate confusion here. 52456. Yeah. All right. Cool. You can customize the local ports for draft connect command, either through the -p flag or through the override ports field in draft.toml. So, and there is a design doc on that. I love the design docs. That's great. Specifying local ports. Consider a deployment.yaml file that has this stuff. And then we do draft connect, and here's the random stuff. But hey, we don't want to do that. So I can do override ports. Here's my example. All right, so let's do that and try that out, because that seems nice. So I have to do draft.toml. Now, where do I put this? Do I put this in the environments.deployment? We're going to do 8081, 8081. And now if I do, let's do connect. Oh, look at that. Okay, so now we're curl localhost 81. All right, so that's nice. Very cool. All right, so the documentation's way ahead of me. If the local port you are trying to map is not available, an error will return and the command will exit, right? So that way, if you like have something else that's camping on 8081, you're gonna get yourself in trouble. Okay, specifying what container to connect to. So by default, Draft will create tunnels to all ports and all containers on the pod. However, you can specify just some of them if you want to, so that's cool. Yeah, so part of what Draft here is, and I think this is interesting because it's definitely a big part of the workflow for something like Draft. But I actually think this is a tool that has independent utility, right? And so I think there's this question in my mind of like, and I almost started doing this at some point, it's like there was work to be done for in kube-control port forward to actually be able to port forward to a deployment, which obviously has some overlap with Draft Connect. But this idea of like, hey, I have a deployment, I want to do a port forward and then tail logs, that's something that's useful outside of the scope of just Draft. And so, I think that would be interesting. And as kube-control supports installing extensions, are there ways to take things like Draft and break them up into things that have some independent utility? Because that's definitely, this is definitely, I think, a useful thing to be able to do, that sort of like port forward plus logs as one thing. So now there is also the question of like, what happens if you have multiple replicas? So we did the auto connect thing. Matt says, yeah, we were interested in not only contributing to the Helm plugins, but that be used as a kube-control plugin too. Yeah, because I think we find these like little snippets of things, and because kube-control has been so difficult to contribute to, everybody creates their own like little utility, right? Like the Kale stuff and stuff like that too. So you can do auto connect in there, which means that when you do draft up, it automatically goes into the auto connect. Okay, so that looks great. So this was the dep. Okay, so I want to go back here. Okay, update the app. So now what we're going to do is we're going to update the app to say something different. And so instead of, well, we already did that with the port, but we'll do hello TGI Kates. We'll go ahead and save that. And now we can just do draft up again. And we'll do the auto connect, because why not? And then if I curl, boom, it looks like it's working. Sweet. Great success. All right. All right, so that is the general flow. Now I know that there's a couple of other interesting things, and I don't think we have time to dig in super deeply on this stuff that I definitely want to call attention to. There's one piece of magic that I thought was really interesting, and if you'll notice back when we did, oh gosh, what was the command? I'm totally blanking now. But back up here when we actually did draft create, okay, so this output is different also, because when we did draft create, it didn't have this nice text, but it says draft detected the primary language as Python with 97.2677760% certainty. This is actually a really, nifty piece of. So Sean says this feels like the most successful trial on TGIK in a while. Great job drafting. No, actually, I think all of the sort of development tool stuff have gone really, really smoothly. I think they've all been really great. So what's happening here is, and I think I saw it. Oh man, where did I see it? There's, when you go to, and I don't know if it's the same thing, but like if I go to like draft here and I click on this, it'll say, oh, this is 91.4% Python Go, right? And GitHub does that stuff for you. I believe that the same thing is happening here for draft to detect the thing. So it's like, so yeah, that general linguist is the so is that. Linguist, which is there's some, okay, so this is a Go version of that, Go port of the GitHub linguist, right? So same idea, so it's not the exact same code that's going on there. But I think, was this in the docs someplace? Troubleshooting references. Where did I see this? It was like, is it like a linguist? So this is blah, 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 blah. Examples, package, linguist. I want to see the troubleshooting. Oh, no, I was looking, okay, that's what I was looking at. So, okay, so here's what happens is the flow, and I forgot where I actually read this. It's really interesting. So when you do the draft create, there's a lot going on behind the scenes there. Let's see. So Matt says that it's described in one of the deps, but and then also what we have here is we have a draft. What do we have? Draft. No, where are the draft? What are they called? The draft templates. The packs. There's the draft pack repo. Where's the pack repo? No, Azure Functions pack. That's not it. Is it someplace weird? So let's look at. Packs.readme. Okay, so here we go. So there's built-in packs. So this is, it's just Azure Draft Packs. Okay, so it's just a directory. Maybe it's not a whole separate repo. But here are the packs. And so this is essentially the boilerplate for these different languages. And so I believe and I forget where I read this, but what Draft does is it uses linguist, which is a sort of, a Bayesian classifier to detect which language is the repository that you're doing, and then goes through and looks at the packs that you have installed and finds one that matches, the first one that I believe that there's multiple, that actually matches the language that you're dealing with here. And so this is where all the boilerplate here that actually happens. And then it looks like there's also some other things that you're going to be detecting. So if it says exit early if the app is clearly not Python. So if you don't have a requirements.txt, a setup.py, or a pip file then you're clearly not Python. But I don't know if that's true or not. But there's a way to actually detect Python going on there. So you can actually write, I guess there's a shell script that helps you figure that stuff out. And so these are things that help to sort of match up, sort of you want to use this template with this pack with this particular directory. So let's see, Anand says, is Linguist Go port 100% compatible to the Ruby version? Matt says that there are a few missing things in the Go port, which we forked and exist in package Linguist. Okay, so there's a fork there. And then you can set up your own custom pack. So if you're like, hey, you know, I like our Python thing always does blah, blah, or, you know, the way that ingress is done, because I noticed that the default chart here actually dealt with, had some options for ingress. If you're like, I'm not happy with the default Python ingress thing, I want to create my own, you know, ingress config with the funky annotations because that's how ingress works. You can go ahead and do that by forking the packs. So that's really interesting then too. And then says, Matt Fisher says, that was the old way relying on Heroku's build pack system. The text scripts are not in master. Oh, I'm not in master. Okay, shoot. How did that happen? If I look in master, now if I look at Python, okay, the detect scripts aren't there anymore. Okay, so you guys switched from Linguist to, or from the detect scripts to Linguist. Okay. So one of the interesting things here is, I think there's probably room to do probably some fascinating things around having these packs also help set up reasonable defaults for other parts of draft. I'm just trying to think how that works. So like this whole idea of like how do we make applications be more self-describing? But I'm not quite sure what that would look like at this point. I mean, at some point you kind of don't want to run the thing. Yeah, not sure. Okay, so yeah, so that's pretty much how this stuff works is, oh, and then there's a whole bunch of stuff here so that you can actually figure out, how do you tell the difference between Java and Gradle? I don't know. Isn't Gradle like a Java thing? I am not Java smart. Okay, and then also the other thing is that when you create this, you can specify which pack you want to use, and that overrides that auto detection magic. If you're interested in creating your own packs, you can simply create those packs in your local draft home packs directory. So there you go, and then you're up and running. So that's really, really cool, and I think that I like the idea that these templates, this boilerplate is extensible. So you can take this as a good starting point and then run from there. And a lot of that extensibility will either be in the Docker file that you're basing this thing on or in the charts. One thing I'm wondering about is like what happens if you have sort of a, how does this work when you have a multi-microservice thing, or maybe you have a sidecar and you're building a couple of things? Does draft actually deal with building multiple containers, or is it only building a single container? I think that's something to think about. And it looks like it's plumbed through for a single container, but I could be wrong. My rule of thumb is that anytime you have a singleton, it's going to bite you in the ass. So there you go. I think that's probably a good overview. We're pretty much out of time. The one thing I did want to go into a quick digression on, just so that folks understand it if you haven't seen it before, was that then we'd have a 12-pack? Oh, yeah, exactly. All right, some good jokes going on there. We need a 6-pack of these. I want to go into the Docker on build stuff. So as we went through the getting started guide, this thing says that, hey, we're doing the Docker on build image, which is going to take you to Docker Hub, and there's some instructions. There's, oh, wow, that's a bunch of gobbledygook. And this really talks about this. But the idea here is the Python on build. So on build is this extension added to a Docker file, which is really not obvious to me, which is it says, here's a Docker file, But if somebody's creating a derived Docker file from this and they're doing a build that actually is based on this, then I want you to run these extra commands. And so it's a way of actually saying, like, this particular Docker image is not meant to be run by itself, but to be a base image for something else. And when you create an image from this, you want to run these commands. And so it works well with this where you don't have to do a bunch of customization because the onbuild stuff will automatically go through and do the requirements.txt by, calling pip and doing all the stuff that you need there, and then go ahead and set up a standard sort of entry point type of thing to run it. So it's a bunch of conventions for running this stuff. If we dig into the onbuild, I'll just show you. So there's the 2.7. So the one that we were using, there's simple tags, shared tags. What's a shared tag? Oh, shared tags are shared between Windows and, this is so freaking confusing. Okay, so if we do latest, well, there's no latest on build. So it's probably, I'm guessing, that result. Oh, here we go to onbuild. So this is going to be this one. So what this says is that, okay, so we're doing a Python 3.6 Jessie, which is a Debian base, because if you use Ubuntu, they try and sue you. And then you do a make dir and then the work dir. So this is all standard boilerplate. And then it says, okay, when you derive from this, copy the requirements.txt up to this thing, do a pip install, and then copy the rest of the data files into the app. So, so this is the way that onbuild works. Now, one of the other interesting things is, for Python, it's probably not a big deal, but for other languages like Go, you don't necessarily need the image that you use for building to be the same image that you push. And so there's the multi-stage build stuff that actually works then too. So if we what happens if we do Go? Docker library, Golang. What does the Golang onbuild look like? Let's take a look. And then we go 110, and we go, let's do stretch, Docker file. Okay, that's the stretch one. Maybe the Alpine 3.7. Where's the onbuild stuff? I don't know. Maybe they don't have an onbuild. I thought they had an onbuild for this. All right. I'm totally off the rails now. Docker library. Okay. Regardless, so that's how the onbuild stuff works, and that's part of the magic that's happening here. Let's see. Matt says that honestly, the default packs are not fully fleshed out. Onbuild images were deprecated almost a week after we start. Oh, are they deprecated now? Oh no. And multi-build support was really new a year ago. Yeah, this stuff changes so fast. Something we want to focus on prior to 1.0. But we're focusing on the user experience first and then the community stuff once the core is stable. Now that makes a ton of sense. So it looks like the onbuild stuff is not the preferred way to do this stuff anymore. I hadn't realized that onbuild had been deprecated. All right, so thank you everybody for joining me. I think we're an hour and a half in. Really interesting stuff going on with Draft. Matt, real quick, I'm going to try and sneak one more thing in here. I believe that there was a way with Draft so that you could put it into a mode where it would automatically watch and update. Is there where did that go? Let's look at just the Draft commands. Oh, no, up here. If I do config connect, is there a way to do a watch? Is that something that you all support? I thought I saw it demoed at some point, but maybe I'm wrong. So that is, it's broken, but VS Code extension supports the workflow nicely. Okay, so if you're using the VS Code extension, that can help to automatically do a draft up, probably with the auto connect. But watch stuff is actually, it was demoed a long time. I think it was when it first came. It might have been before you guys even launched. I think, there was a sneak peek at some point. And the VS Code extension, I have my kube config set up so that it's difficult for me to use the VS Code extension, but I'd love to demo that at some point too. So, all right, and Yeah, and then all the stuff that we actually created here, including like the chart and the draft.toml, you would usually check that in, but because we're using the example app, there's no, it's in the git ignore. So, all right, cool. So that's all I have for today. Thank you everybody for joining me. Hopefully we all learned a little bit. It's great to see these different tools and compare and contrast. Really interesting stuff going on there. And I can definitely see for, if you really do need to do a full build, this totally makes sense. And I think that the approach of create the image and push it works pretty well, regardless of whether you're doing an interpreted language or whether you're doing a compiled language. I think, if you're doing interpreted language, you're going to get tighter loops, and if you're doing something like Ksync, those things can be a little bit trickier to set up and a little bit more invasive. If you're running stuff locally and you're building very large binaries, or if you want to do debugging, then something like telepresence, where you're actually bridging the network, may make more sense, right? Because I think, these tools like Draft and Scaffold, all the example applications are relatively small. It makes these times be the sort of cycle times be relatively reasonable. If you were building, say, 100 megabyte binary in Go, every time you hit save to get that stuff reloaded, you'd be uploading 100 megabytes up to your cloud, which is obviously, depending on your connection speed, could be a problem. Whereas if you are running that stuff locally and you're using something like telepresence, then you're just moving network traffic back and forth, and you can actually sort of make those cycle times faster because you're not hitting a lot of networking back and forth. That stuff, the example that we're doing here is we're running against a remote cluster. If you're using Minikube, obviously you're not doing that Docker push, and so you're not uploading stuff, and so that would definitely speed up these times also. But my feeling here is that the primary reason why folks want to develop against Kubernetes is because they're relying on other things that are part of a Kubernetes ecosystem, like other services that people are running, and not all that stuff fits in your laptop. So I really think that the things that'll drive folks to any of these solutions is going to be the fact that they're working with as a smaller piece of a larger application, and the rest of that application is running in a remote cluster. So that's one of the reasons why, as I've been demoing these things, I haven't been using something like Minikube and running locally. All right, so thanks for joining me. Okay, so I said that 5 minutes ago, but here we go. Thanks for joining me. I'm going to close up now. I will see you all next week. I don't know what I'm going to cover, so if you have some good ideas, send them my way. I definitely, we have some stuff that we're going to be announcing next week. Maybe I can cover some of that and talk about that at TGIK. And then I also have to figure out how to get remote guests on here, because I definitely want to have folks from around Heptio demoing things like Ark and Sonaboy and Ksana and other solutions, and give other folks a chance to actually share the stage a little bit. So, all right. Thank you so much for taking the time, and I will see you all next week.